Okay, so this is going to be a overview of databases. We've been talking over the course of the term about Excel as a tool to work with the data, to turn data into information. And this is the other major piece of technology that we use that's used for that purpose. We've been talking, I guess, over the course of the term about the differences between databases and spreadsheets. So that's going to be something, this will be coming back as well. Okay. Um, so, we talk about the what, the where, the, the when. We're going to talk about the why. So, what is the value of a database? What does it really give an organization? So, to start off with, every enterprise system requires stored data. All right. We've always had stored data. So, like libraries are full of books, which are all stored data. In the case we're talking about here, we're talking about stored digital data or electronic data. All right. So this is going to be every application, and really what this digital data is really digital memory of an organization, all the activities that are going on, how much, all of its products, all of its transactions, all of its customers, all everything that goes on is saved and recorded. All right, so that's what the database does. So it really provides a way that we can capture, process, and store data. All right, so at the core of every application, if you look at anything on the internet, for the most part, anything that you go out on the internet, so Amazon.com or Twitter or anything, at the core of that is some sort of database. Now, a database, there's different types of databases, but this is but I think when I use the term database here, I'm using database with the small d. It's a storage, it's a way of storing data. All right, a little bit of a history of this. Uh, the first business databases were really developed in the 60s as part of IBM, which really ran the mainframe business at that particular point in time. It was part of the Apollo project. They developed a product called IMS, Information Management System, which was one of the first commercial databases that had gained large acceptance. All right, and it was built on something we call a hierarchical model. So it was sort of a tree structure. So you'd have you have different levels which could then explode out. And this was really a very successful product. All right. But so what we're working with now, when we talk about databases now, is what we call a relational database, which is it's a little bit of a different animal than a hierarchical database. So a relational database is really the mainstream architectural model for databases since probably starting about the mid '80s through now. So it's been pretty well established, about 40 years. All right, where it came from, Dr. E.F. Codd from IBM published a paper in which he described a new approach to databases that were based on relational algebra. So relational algebra is dealing with set theory. And you have different sets, and you look at the union of you'll have different sets of things, objects, and then you'd have a union of set, a union which would be all objects across both sets. You'd have an intersection, which is the common between two and the other, and then you have a null set, which would be an empty, something that would be only in one but not the other. All right. So he adapted this relational algebra and turned it into a database model. All right, and it was really the first commercial one. The first big utilization of this relational database was by Oracle in the late '70s, and then that was really the next big innovation. So all through the '80s there were the database wars of different organizations developing these relational databases and bringing them to the market. So it was a big thing at the time. All the applications we talk about, if you go into a business and you look at their applications, at the heart of those applications, you're going to find a relational database. So everything, all the data we store in things like ERP systems, customer relationship systems, sales order systems, everything, for the most part, all of these things will have some type of relational database that where all the data gets captured and loaded into. All right. So the difference between a database and a spreadsheet. So we've talked about this over the course of the term. All right. So there's some. They look as we look at this, you'll see some similarities because they are both doing kind of the same thing. They're both working with data. It gives us the ability to organize data and turn data into information. All right. But there are some differences. All right. And the big difference is fundamentally, I would call it the main differences all lies within rules. All right. Spreadsheets are designed to be very flexible and adaptable. All right. So, there's not, we can, as we've seen, we can enter data, we whip these things together very quickly. And then we can come back and kind of, fine tune it. Databases, on the other hand, are designed to be very specific structures. All right. So you have to define everything in a database before you even begin. So you have to design it, you have to define it before you do anything with data. Whereas with spreadsheets, you can just start banging them. You start entering data. First thing you do is enter data. Also, spreadsheet stores data in rows and columns in a worksheet. All right. Databases store data in rows in tables, and those tables can be related together. All right. So think of a kind of a relational database as kind of like multiple worksheets in an Excel workbook. All right, but designed really from the ground up, to be interconnected together. And we'll talk about this in a second about this idea of keys and being able to tie information across multiple tables together in keys. Um, the other thing about databases are databases scale to millions of records. All right. The mathematical basis of it, and also the requirements to be as structured as possible up front. What are the byproducts? What are the advantages of doing it that way? Is we can scale, we can add millions of rows in a database. Whereas with the spreadsheet, it's good for data measured in hundreds and thousands of records. But as you start getting into really substantive, it really becomes challenging because databases are not necessarily designed for the ground up for that. All right, we've seen that Microsoft has taken database functionality, database style or like functionality, and it has embedded it into Excel. So, but as I said, it doesn't turn it into a database. All right, so there's some key differences between spreadsheets and databases. So here's some of the key concepts. So some of the key concepts, some of the key terms we're talking about with databases. So we have, we talked about a database, which is the collection of records. We have a relational database. So a relational database is a database based upon Codd's rules. All right. So those are a different, there's a difference between those two different things. Within a relational database, there's a particular structure. We call it like a hierarchy. So what you start off with, you have the database. Databases contain tables. Tables are made up of records, and records are made up of fields. All right, so kind of the counterpart to, if we want to use an analog of Excel, the database would be the workbook. The table would be the worksheet. The records would be the rows, and the fields would be the columns. All right, so that's the kind of the hierarchy of how this is set up. A database management system, or DBMS, is software. All right, so a database management system is not the same thing as a database. All right, so a database is a collection of data that's structured together in some fashion. Whether it's relational or hierarchical. A database management system is a piece of software, which is what we work with, which operates on our behalf. It sits between ourselves and the data, and we interface with the DBMS, and the DBMS is responsible for the execution, the operation of everything that goes on inside of that database. And it's very, very sophisticated software that's designed to be able to manage this database, this relational database product. So it does everything on our behalf. So what happens is there's a lot of things that as we saw within Excel, where we were creating formulas to kind of pull data out of tables, that we had to be you know, very precise about addresses and things of that nature. Within um, databases, relational databases, we don't need to know any of that. We formulate what we want to get out of the database. We give it to the DBMS, the database management system, and it returns the answer to us. All right. So, we say, what is a database? Very large integrated collection of data. And the idea is it's designed to model the idea of a database design. It models real world enterprises. All right. So when we structure things together, so if we have an application that's doing sales order processing, what we will have is we will have tables that will contain information about like the items we're going to sell. All right. And then the order number of a particular transaction and pricing information, things of that nature. So, to that end, if you look at a relational database and you look at the tables and the names of the tables and stuff, you can get a sense of, you have a better sense of, what it does, as opposed to a spreadsheet, which, if you don't put any documentation in it, it doesn't, you have to go in and really kind of figure it out yourself. All right. This idea of relationships, which really lies at the heart of this relational database, it connects this collection of information together into something that we can, what we do is we can load data into it, we can get data out of it, we can analyze it, we can do any number of things. So here's a picture of a relational database. All right, so this is fairly simple. This is a employee. So if you look at this, you kind of read it, what you have here, you have an employee table. These are all tables. So this is the employee table. This is a device table. This is a department table. And this is a department employee table. All right, so this lists out the employee, lists out all of the employees that are in the organization. The devices table lists out all of the devices and who they've been assigned to. All right, so we can have like 500 phones, of which we issue one to every employee, and then X number will be in inventory. All right, so you could have something like that. Departments, we could have X number of departments, and then we assign employees to departments. All right, so you kind of say, when I say it kind of it models real life structure. So an employee is all of the different characteristics we associate with an employee. All right, a device is all of these. These are all of the characteristics we associate with a device. All right, and then what you'll see is these arrows kind of connecting these things together. What these arrows describe is what we call the relationship. This is the nature of the relationship. So we'll take between employee and device. So I have an employee. An employee can be issued, a device for them to use. All right, and it can be any number, any form. All right, and then what you've got is there's a device. And you kind of look at these arrows and you see these kind of cryptic symbols here. What this means is the symbols describe the relationship. All right, so we use the little crow's feet here. This is a many to one relationship. So what that means is for every one record I have in one table, I can have many records referring to that table. All right. So, one employee can hold many devices. All right. It could be one, could be, 100 million, whatever, whatever that number would be. All right. No limit on that. All right. From a department employee, this is the intersection between, what employee is assigned to what department. So, a department in this case, this table here kind of links the two of these together. All right, so between both of these two tables, like the employee is assigned to a department has employees in it, and this table right here, this deployment department employee table contains the values which allows us to tie these two together. So, as we're talking about this, kind of just reemphasize the components of a data, relational database consists of one or many tables, tables made up of one or many fields. And then we have a collection of records, across all the fields. That's a record, and a table can have many records. All right. So this looks like, you can replace the terms row and column with records and fields. All right. But they do the same thing. And if you want to look at Access, Access actually looks kind of like Excel in a lot of its features because it's part of Microsoft Office, and there's a common kind of common structure they work with. Right. So this is our, as we say, relational database, collection of tables that are related together based on a common field. All right. So another example of a relational, of this relation: departments, classes, instructors. Right. As we can see, it models real life things. All right. Departments have a name, they have a chair. Instructors have email address, phone numbers, and are assigned classes. All right, so it's kind of describing this is, a department has classes, all right, and they're tied together by the department ID. All right, and that's a one to many. One department can have many classes. Going the other way, a class can only belong to one department. And then conversely, with the instructors, a class can only have one instructor, but an instructor can teach many classes. All right, so this is this is really the common layout when we talk around relational databases and the structure of relational databases and how this stuff is organized. So database management system, we talked about that a little bit more. It's software package, so it's software designed to store and manage databases through which users will interact with data. All right, so some of the more common ones: Oracle, which is where the first company that brought relational databases into the market. But everybody, so we've got a lot of them out there. So IBM DB2, which was ultimately IBM brought their product forward and retired their old systems. Microsoft got into the game with Microsoft SQL Server. MySQL is an open source system, which basically means it's licensed. There is no license on it, all right? So you don't have to have a license. With these other ones, you don't really buy the software; you buy the license. All right, and then we have Microsoft Access. So Microsoft Access is a desktop application, runs on a workstation, only runs on Windows. All right, so it's just a Windows. It's been around a while, but it does. If you look at all of these DBMSs, these database management systems, obviously the code is different and the functionality is different, but at the core, it does the same. I mean, it interacts with a relational structure and lets us retrieve, enter data, change data, update data, in the database. All right, that's something all these things do. So the basic functions, if I have a database management system, the things I need for it to do. Number one, we need to be able to create the tables up front. Remember, we talked about the difference between a database and a spreadsheet is the rules. So up front, we have to do a design. We have to create the tables, define all the relationships. All right. And then once we do that, then we can add data to the tables. We would say maintain. All right. We maintain data, so we can add data to it. We can update data. So once I add it, I can change it or I can get rid of it. And this is really what we call the maintenance of it. We can query the data. So what a query the data means is we can ask questions, and they will give us answers. The DBMS does this for us. When we get the data back, we can report on it. So we can either there's functionality in depending upon the DBMS. They may have something built into it. In the case of Microsoft and Access, they've got very tight integration between Access and Excel, so you can actually store the data and query the data in the database, and then load it into Excel and do reporting with it. And then finally, what we do is we control access to the data. So if you want to control, uh, you want to make sure that especially sensitive data, because a lot of this stuff is in organizations, the data can be very sensitive. So you don't necessarily want to have everybody with the ability to go, and manipulate it, or either adding it or deleting it. So that you have to have an ability to control it. Each one of those databases, those relational databases we showed, the DBMSs, have this capability built into them. All right, so there's a couple things around COD. When COD defined his rules, actually, I think there's 7 or 9 rules that he defined. He says describes a relational database and the things you have to do to it. All right, so he describes this stuff as integrity rules. All right, so in other words, in order to have a database, a working relational database, you have to have um, what he first calls entity integrity, and all that means is every record in a individual table is unique. The way you ensure that is you pick one field which is different than every other field in the table. We can do this a couple ways. Either you can find a number that some attribute, some field that is guaranteed to be unique, or you can actually put what we call a surrogate key. You can just use a fake number that increments from 1 to infinity as you go, and that allows us for the entity integrity to be maintained. We also have data integrity. What data integrity means is we define the rules. We define a set of rules that controls what goes into a database. All right. So every field, we have to define: is it a date? Is it currency? Is it text? Is it all that stuff is up front is explicitly defined before we load any data into the table. All right. And the database rules are designed to ensure that and protect it. All right. And then third, we have what we call referential integrity. Referential integrity means that the relationships between two tables are maintained. All right. So what that means is if I've got a common field linking two tables together, that value is present in both those tables. So if I have a table, so I have two tables, I have for example, a phone number, and I have a phone number in one, and there's not a matching phone number in the other one, you've broken referential integrity. So you'll hear people use the term broken databases. That's kind of what a broken database is. If you break the relationship between tables. All right. So these three elements here, these three integrities, is what COD says we need to have in a relational database in order for it to be a relational database. So each field is a distinct name. All values in a field represent the same attribute. So if I've got a particular field, I know everything in that column has the same value. Every record is distinct. That's what we call the entity integrity. And we do this by ensuring a primary key. Now, what happens is one of the things to be aware of with these rules, with COD's rules, is that it doesn't necessarily, you can do databases, you can build a database and not have it 100% compliant with all of COD's rules. All right, so like for example, in Microsoft Access, this idea of every record has to have a primary key. In Access, you don't necessarily have to have it. It is a best practice, and you really should. But if you have some circumstance where you didn't want to, you kind of whip something together, and if you didn't have it, it lets you do it. Whereas other databases absolutely require you to do it, or enforce that as a rule. You cannot create a table if you don't define a primary key. Two other bits of information. Always interesting. The order of the columns in a table, it doesn't matter. All right, so we can whatever columns you have in there, it doesn't matter how it's stored. We can retrieve when it comes back. Uh, we can organize. We can sort it when we as we bring the data back. Also, the order of rows. All right, so what happens is maintaining order in a table is takes overhead. It takes, if you had to say a table is always the order of rows has to be it always has to be in ascending or descending order. What will happen is every time you entered anything into that table, you'd have to go back and resort. So there'd be a constant thrashing. So the way Cod got around that is he says, okay, it doesn't matter what the order of the rows are. When you retrieve the data, then you can sort it. All right, so that's basically this is all from Cod's rules. All right. To create a table, what we do is we name the fields, define the properties. All right. Figure out what's the data type, and what's the size of the fields, right? And then also a description of the fields. If you compare that to what we did in Excel we just kind of banged away. We can enter data into cells and then come back later and change it. All right. Whereas databases, no, you do this up front. All right. That's one of the requirements. Then we define what field. Once we define all the fields, we figure out what field is going to be the primary key. So the primary key is this is an access. This is a qualifier. This is from access. Primary key is not mandatory, but it's a big, good idea, best practice. Assign a primary key. Right? Primary key, the primary key must uniquely define each record in the table. All right, so that's a unique requirement to be unique. And a primary key consists of one or more fields that can. So what happens is a primary key can either be one field, an individual field, or it could be a combination of fields. All right, so whatever it takes to make that field, to make that record unique, you can do that. All right, if you have a bunch of fields together, we call it a composite key. So what is Access? So Access is a relational database system for that is part of Microsoft Office. Right? The core, as a DBMS, it's a software engine that sits between us and the data and operates on our behalf. Integrated in Microsoft Office for Windows, it is not in Office for Excel, nor is it in Office 365 online. All right, so this is, Access is kind of a legacy product because back in the early days of Microsoft Office, what was happening was there was a lot of competition. There was a lot of other databases that were out there. So Access was just one of a whole bunch of different machines. Now what's happened is as time has gone on, that stuff has kind of faded away. All right, but Access is still around and it's still part of Office, and it's still and Microsoft's done a very good job of maintaining it and adding functionality into it. And so it's still the challenge that Access has is you have to learn how to write queries and understand how to work with relational databases, as opposed to Excel where you could just type stuff into it. So so Excel is the flagship in Microsoft's perspective of the world. So they've taken to adding functionality, database-like functionality into Excel, but we still have Access. All right. Talked about Visual Basic, the same kind of things we could do in creating macros. We can create macros in Access too. Right. We talked about the emphasis. So one of the things a database has to do, and why there are rules and why there are so many rules associated with the databases, you got to ensure that the data is good, that you maintain quality, and we're trying to establish a level of data quality, maintain that level of data quality, and sustain it. It's a full-time job. All right. So there's a lot of functionality that's in a database that is designed specifically just for that purpose. All right. So we talked about garbage in, garbage out. What is garbage in, garbage out? It is it means that if you put bad data in, there's nothing that's going to make it better. All right. So the challenge is to maintain and sustain that. And really the rules and the structure that's in a relational database is fundamentally designed to do that. Now, even though the database is designed to do it, people find a way to still put data. You can still put garbage in. It just makes it a little bit more challenging. Talked about our design rules. The entity integrity, which is every rule is unique. Data integrity. Data are designed only. We're designed to collect and store only valid data. All right, that's where the rules are. We define what the rules are. The rules determine what should be valid. And then referential integrity, where the relationships between two tables are maintained. So some of the stuff we look at when we talk about data validation, some of the things we can check for. So the date format, the range, consistency, and completeness. So that's really something when you're working with databases is something that is kind of really at the forefront of the work we do. It has to be major emphasis on the maintaining the validity of the data. All right, so some of the stuff around the things we can do within this is dealing with access, but there's other databases have similar kind of capabilities. So the idea of putting the right data type in, the right field size, the captions, set default values, make the field required or not required, data validation rules, input masks. So all of these things can be done to make a database, and this is all the stuff that's built into the database. So there's four within our relational database, and kind of what we call the relational principles. The relational database, and we'll show this in Access in the next lecture. But relations are maintained between the two tables, all right? And we define a field, a primary key and a foreign key, which defines what that relationship is. We'll show you that when we start talking about joins. Right? And then we talked finally about a concatenated or composite key, which is, it's unique and it's made up of more than one field. Just a quick, walk through, the things we need to do if you're going to build a database. This is the steps you go through. All right. So once we do all this stuff, then we can add the data. All right. So we design it, identify major objects, add specific details, define the primary key, figure out the data types and size of all the fields, whatever our additional restrictions are, relate the tables, and then, and only then, do we add data. All right. COD's rules are really built around this idea of relationships. So we have a one-to-one, a one-to-many, or many-to-many relationships between tables, between entities. Okay. So what that means is between any two tables, if one-to-one relationship means there's a match. There's one record that should match across two tables. One-to-many is the most common relationship we see, where entry in one table can have many entries in the other table, and it's a two-way relationship. So, the way you would describe it is one entity, one sales order can have many items. Each item in a sales order can only have one sales order number. Right. And then we have many to many, which we take all the rows and all of the between multiple tables and we match them all together. All right. So usually you don't see a lot of many to many because that's what ends up happening is it creates what it calls a Cartesian product, which actually generates like thousands upon thousands upon thousands upon thousands of relationships. So it's usually, and the one to many, the one to really grasp and work with in relational, when we work with relational databases, is really the one to many. So, and this is maintained in Access, and we'll talk about this in a little bit. So this is the things we can do. This defines the relationship between two tables. Right. And that is it for our introduction to databases.